In this question, we have two situations. The first one, we were told x and y is connected by a string, and y to the hanging block M0 is connected by a string. If we look at the forces involved, we have this Fg, and we have this tension, and we have the tension here, so we'll call this T1, T2, and this would be minus T1 plus T2, and then we have minus T3 and a plus T4. Now, since we know at every juncture here that the minus T1, T2, minus T3, and T4 are all equal to each other and they cancel each other out, so that the net force on the system is simply the weight. So the net force is the sum of the forces, and the sum of the forces are Fg minus T1 plus T2 minus T3 plus T4. And what we know is, since at no point in here is any molecule accelerating relative to each other, that these forces are netting out to zero. So that then we know the net force is equal to Fg. And we have the mass of the system being accelerated by the net force, mg. Now, the mass that's being accelerated is the entire system. So that's the mass of x plus the mass of y plus m0. So the acceleration is mg all over the sum of the masses. So therefore, we also know that the acceleration will be less than g. So that's what's happening with the first case. Figure 2 says it's identical, except instead of this being a spring, instead of this being a string, it's a spring. So everything else looks to be the same. We have our force of gravity, and then we have our minus T1, and then we have a plus T2. And then what we have here is a minus force of the spring. A minus force of the spring. So our net force will be the sum of the forces, and that is ma, and the sum of the forces will be Fg minus T1 plus T2 minus Fs. So ma is Fg minus Kx. So the acceleration of this system will be mg minus kx all over the masses involved. Now, initially, the masses involved are going to be m0 plus y, plus mass y, because as this starts to accelerate, this is tight, and this will accelerate away. And this is at the spring is in equilibrium position. So this y will accelerate away until T2 is equal and opposite to the force of the spring. Once that occurs, then x will start to accelerate. So this is at time 0. And then later, acceleration times 2, it will be exactly the same equation. mx plus my plus m0. So what's occurring over here now is the object takes off and it accelerates, and this net force Fg is now just accelerating y and m0. So the acceleration will be greater. And then when the force becomes equal, the acceleration will be the same. So what that means then, if the observed acceleration is changing, if we were to take mo and drop it, the acceleration would be g. Now, when it's accelerating connected to y, that acceleration will be less than g. And if the acceleration is less than g, that means it's being slowed down because there is a tension. And then when y comes on board, or x comes on board, the acceleration will be even less than g because the tension is increasing. These two bodies are impeding the fall of m0 more, so therefore the acceleration will be less, and that's because there is a greater upward tension. So now, if we look at our choices, we want to break these down into the yes, no, the conclusion part, and the clauses. Let's focus on the clauses first to eliminate any factual inaccuracies. The net external force exerted on both systems is the same. And that is yes, that's the force of gravity. So that is true. Because the tension in the string connecting the block to the cart is determined by the masses of cart Y in the block. That is not true. That is false. The tension in the string is determined by the mass of the weight of the block hanging. Because the net external force is different, well, that's the opposite answer of above, so we have already established that that must be false, because it's the opposite of the first choice, which we said yes to. Fourth choice, because the tension in the string connected to the block is constant in one system, but not in the other. Well, let's first see if it is constant in one system. Well, yes, in the first system, the tension is going to remain constant throughout. And we said in the second case that since the accelerations will be changing, that means that the tensions will be changing once the block X comes online. So because the tension is constant in one system and the other. So that is a true statement. So now it comes down to, we have two true statements, so is it yes or no? Let's go back to the question. Is the hanging block's acceleration the same in both systems? Well, the answer is no. We already established there will be that lag. So that choice is out. And that's all the reasons why this fourth choice is the correct answer. Now, we might have been able to answer this sooner because we'd already teased out that it was no, and then we can eliminate this one. But I wanted to make sure that we thoroughly understood why every clause was correct or incorrect and why.